Hi everyone, welcome to another episode of my Nextflow tutorial for bioinformatics. And so for this episode, we are going to write a Nextflow pipeline for trimming. All right, so we are going to trim using fastp. All right. So before we start the exercise, we need to make sure we have all the PC requirements satisfied. So we need to make sure we have Nextflow installed. You should also have fastqc, multiqc, and then fastp installed. Now, if you don't have any of these tools installed, don't worry, we can still use Conda or Mamba or Micromamba to install these two. That's what I'm actually going to do in this exercise. So just make sure you have Conda installed or Mamba or Micromamba. All right. So instructions for installing all these tools can be found in the description box. So just make sure you have them installed. Again, you can have Nextflow, fastqc, multiqc, fastp installed, or you can just make sure you install just Conda, Mamba or Micromamba, and then we can proceed. Check the description box. You will find the instructions to install all these tools. Okay, now this is what we are going to do. I will just shift to this. So this is the overview of the pipeline we are going to build. It's a simple pipeline, and this is the overview. So first of all, we are going to make sure we have our FASTQ files, and then we will push it to Nextflow. So in Nextflow, we will use the channel from file pairs to get the FASTQ files, or we are dealing with paired and reads. That's why we have from file pairs. And then once we get the FASTQ files, we are going to, these FASTQ files are going to be our raw reads. So what we are going to do is to run fastqc on the raw reads, and we are going to generate our report. Then this FASTQ files, we are also going to trim the FASTQ files using fastp. So this is a tool for trimming. And then after trimming, we will generate our FASTQ files, which is great. Now the trimmed reads, we are going to run fastqc on it, and we are also going to generate some reports. And so the two reports, the one for the raw reads and the one for the trimmed, we are going to aggregate all of them together, and we are going to run multiqc on them. All right. So once we run multiqc, we will generate two reports: a multiqc report for the raw reads and then a multiqc report for the trimmed reads. So the reason why we are also going to use multiqc is that when we have your fastqc report, these are several files. So we use multiqc to aggregate them. So we aggregate the fastqc report for the raw reads and also for the trimmed reads. So this is what we are going to. So at the end of the day, we will generate our report, the QC report for the raw reads, and then for the trimmed reads, and we're also going to generate our trimmed reads, which are also in FASTQ format. So that is what we are going to do. So I'm going to explain the different steps we are going to use in Nextflow so that beginners will also understand and use that knowledge to build their own pipelines. And let me also say that the script for the tutorial is available. So for those who want the already made script, there's a link that you can use to download them. So basically, we are going to follow these commands. Okay, so that's what we are going to do. So let's proceed. So let me also say that, so before you write Nextflow, or before you write a Nextflow script, you need to make sure that all your commands work before you write your script. All right. So Nextflow itself is not a magic bullet. It facilitates your work. And so you need to make sure that the commands you are using, the tools you have, they are already working, and then you can now put them in Nextflow. So it's important you take note of these things. Okay. So without further ado, let's shift to the terminal and then get started. All right, so we are on the terminal now, so we can proceed. So we are using a Linux. I'm using a Linux system. You can also use macOS. That's also fine. All right, so just make sure you have a Unix operating system. That's how we do it in bioinformatics. All right, so first thing we have to do is to install the tools that we will need for this exercise. So I'm going to use Mamba to install, but if you have them installed, that's great. If you don't have them installed, instructions for installing the tools can be found in the description box. So I will start. So I'm going to say Mamba create -n, and I will say bioinformatics. So I'm going to create an environment called bioinformatics, and in that environment, I'm going to install the tools I'll need for this exercise. So one of the tools is what? Nextflow. I will install Nextflow. I also need fastqc. All right. And I'll also need MultiQC. And I also need fastp. These are the tools I'll need. I need to also specify channels. All right, so I'll say -c bioconda -c conda forge. Now I'm going to install the tools. And let me say that, so I'm using Mamba, but if you have Conda, then you can change Mamba to Conda like this, and then it will also install. But I'm using Mamba, so this is how I'm going to do it. So I'll install the tools. So Y for yes. Once we do it, Mamba or Conda or Micromamba will install all the necessary packages for us. So it will take some time. So let's just wait. All right, installation has been done. So if you want to activate and have access to the tools, in my case, it tells me I have to activate this environment. So all I have to do is to activate it and proceed. So I'll clear the screen and I'll say Mamba activate bioinformatics. So once I do that, it's activated. So I can proceed with my exercise. All right, so let's clear the screen and continue. Okay, so we have activated our environment. We have the tools we need. So what we have to do next is to create a directory for our project. Ideally, whatever project you do, you need to make sure you have a directory for it so that you don't accidentally modify some files. So we will create a directory called Bioinformatics. I'll say make dir Bioinformatics. This is Linux 101. So I'll create this directory, or if you have a specific name for the project, you can also do it. That's fine. So you can even say trimming, whichever one, that's fine. All right. So just make sure you have a name that describes what you are doing. Okay. So now that I'm even saying this, you can just say trimming. That's fine. Okay. But I'll just say bioinformatics. All right. So let's keep it simple. So I'll create this directory and then I'll cd into it. Nice. So now that I have done this, we need to also now get the example data set we'll use for this exercise. All right. So the data set that we are going to use can be found here. I'll just show you. So this is the page. All right. So this is my GitHub repo. Okay. So this GitHub repo here has the data we are going to. So I have get to this page first. The link to this repo is in the description box. I repeat, the link to this repo is in the description box. So when you are here, you need to make sure you get this file, staff Orios batch1.tsc. So when you click it, all right, so you are going to see all these links. So it is these files we are going to use. All right, these files, let me just show you one of them. So these are Illumina, MySQL 4 Staphylococcus isolate. Okay, the original paper too, I'll leave it in the description box. So this is just some of the isolates. All right, so I'm using these ones here. So I have 3 samples. These are paired end reads. So I'm going to use these ones. All right. So what I want you to do is to make sure you copy this. All right, we are going to use all these links. So you can copy them. You can also download them one by one, but I want us to do a batch download on the terminal. So I want us to copy all these links. So first highlight them and then copy them. All right. Then I want you to go back to your terminal. Let me just do it here. Go back to your terminal. And then on your terminal, I want you to open a text file, just a file, normal text file. And then we will paste the links in that. So I'll use nano. So I'll say nano and I'll say links.txt. You can use any text editor, vim, whichever, that's fine. But I'm using nano. So nano, I specify a file, I open it, then I'll paste the links there. All right, these are the links. I'm going to paste them there. Then I'm going to exit. I should have 6 of them. I'm going to save changes. I'll exit and then save changes. Now, if I do an ls, I'm going to find the files there. Okay, the file. So there's it. I can do a cut. I'll see the links there. All right. So now what we are going to next is to download the files. All right, there are different approaches to download them. That is fine. All right, so because I'm using Linux, I will just do a batch download using SAX, but you can also just use wget and specify each of these links. All right, you can just use wget. If you have any challenge, you can just use wget or curl and then specify the links one by one, like this one here. And then just hit your enter key and then to download. But I'm going to do a batch download, so I don't need this approach. What I'm going to do is to do this. I'm going to say cat links.txt. I'll bring a pipe and I'll say xax-i-p uppercase 4, and I'll say wget, and I'll paste this. I'll write this. So there's a placeholder for all the entries. So I'm going to do 4 downloads at a time. So that's why I have -p4 here. So take notes. Now let's execute this command. So once we do it, it's going to start connecting to the server and then download the files for us. So we are going to get a total of 6 files. So these are paired end reads. And so that means we are dealing with 3 samples here. So it shouldn't take much time because these are small files. All right, we have our data downloaded. Let's clear the screen. Let's ls. We are going to find the files here. Okay, that's great. That's good news. Now we need to organize these files. So we need to create a directory for it. So I'll just say make dir, and I'll say fastq. ls, I'll see the directory called fastq. I'm going to move these files in there. I'll say mvn star.fastq.gz. I'm moving all files that end with .fastq.gz to that directory. So I'll just specify the directory, which is fastq. So this, once we do that, nice, we have our files organized. ls into fastq, we are going to see the files there. That is great and wonderful. So congrats for getting to this part. Okay, now we have the data. So it's now time for action. All right, so we are going to start the Nextflow tutorial proper. Okay, so we are going to start. So that's what we are going to do. I need to show the scripts. All right, so we have our script here, which we are going to use. So for the sake of beginners, I'll go through this script step by step and explain a couple of things so that you can build on it later. So we need to make sure we supply our fastq files, and then these are paired end reads, by the way. So we are going to supply the paired end reads. And by the way, I have a tutorial on Nextflow that explains how to input paired end reads in Nextflow. So for a detailed explanation of that approach, of this approach, just watch that video. The link to that video is in the description box. So basically, we are going to use a channel, and then we are going to specify a pattern to get Nextflow the paired end reads, and then we are going to first do the trimming. All right, so once we do the trimming, then we are going to make sure that the trimmed fastq files, we get them and then run fastqc. All right, and then we are also going to run the raw reads. The raw reads itself, we run fastqc. That one will also be done separate. All right, so that's what we are going to do. So the raw reads, we will trim it, and then we are going to do fastqc. So take note that the fastqc analysis and multiqc is entirely separate from trimming, and so that is why we can separate them. All right, so first of all, let us do this. We need to make sure we have our trimming command ready. It's important we do that. And also, let's do some tests first. We need to do a test before we start the exercise. So let's do this. I'm going to shift to this other screen. Let's see, and then we are going to run. So what we are going to do is to create our script first, our Nextflow script, and then we are going to do the modifications in them. So let's do a nano. You can use any text editor of your choice again. I'm using nano. I'll say nano, and I'll just say trim.nf. This is the script I'm going to use. So I'm naming it as trim.nf. All right. I'll open it. Now, when I open it, the first thing I'm going to do is to indicate our workflow. Okay, so this model is required for running your analysis. Okay, it's a requirement. So in this, we can now put whatever we want to run in it. So to do our test run, what we are going to do first is to just read in the files and then just view them to make sure we have something to start with. So I am going to say channel dot from file pairs, and I'll say params dot reads. All right. Now param dot reads, this params here is needed because we are going to supply the inputs on the terminal. That's what we are going to do in this tutorial. In real world situations, you may be using the script on different data sets, so it makes sense to supply them on the terminal. So that's what I'm going to do first, and I'm going to say .view. All right, this is just a test run. We will later modify it. That's fine. So let's exit, and then let's save changes. Do an ls. We are going to find your trim.nf. Now let's ls again into fastq. We have our file there. Now, these are paired end reads. So what differentiates one, let's say read 1 from read 2 is the _1 and then _2. So _1 is for read 1, _2 is for read 2. So based on this, we can specify the pairs, okay, the file pairs into Nextflow. So to do that, we will just say Nextflow run, and I'll say trim.nf, and I'll say -- reads. It's double dash, or let's say minus, whichever one you say it. So -- reads, and then we will bring a quotes, and we are going to say fastq / and I will say star curly brackets _1, comma _2, curly bracket close, and I'll say star fastq.gz. That's going to be the pattern, and then we close it with another single quote. So this is how we are going to supply Nextflow with our paired end reads. I've covered this approach in detail in another video, so if you want to get more details on this, you can just check the description box. The link to that video is there. All right, so let's run this simple script to see what we get. So when you run it, all right, what we have to see is this. All right, so once we see this, that means that everything is okay. We can see our files, our paired end reads. So you should see something like this. Okay, it's very, very important. So with the paired end reads, that's what we are going to see. We are going to see the sample name. It's automatically strips that for you, let me say extract that information for you, and you have read 1 and you have read 2. So it does that for all the 3 samples. So this is a good sign that everything is okay, and so we can proceed with our exercise. All right, so this is what I wanted us to test. So there's a test run. Okay, so now we can continue. Let's clear the screen and continue. Okay, so let's get back to the script again. So I'll just do nano. So it's trim.nf, and then now I'm going to clear everything and then just redo it again. All right, so just take note of that. I will just clear everything. We will start afresh. So this is just a test run. We are now going to do everything proper. Now this workflow, this one should always be there. We will come back to it. So we are going to start with the trimming using fastp. That's what we are going to start with. All right, so we do that using process. So process, these are basically tasks that you can run. So you call them in the Nextflow environment here, this workflow environment here. You call it here, and then it's going to run. Okay, so we are going to start with the trimming. That's what we are going to start with. Let me just shift to the other screen for us to see the script. So this is the process trim. That's what we are going to do. I'll just so we have this, I think, yeah, so this is what we have. That's fine. So this is the process. All right, now let's first focus on these things. I will explain them for the sake of beginners. So in Nextflow, for a process, the key things you need are inputs and then outputs, and you also need your scripts. Okay, your scripts or command or shell or whichever. Okay, I use scripts. So you type process, you give it a name that should be descriptive of what it's going to do. You have your curly bracket to start and curly brackets to close. All right, I think I'll try to enlarge it. Yeah, so now I think this is better now. So we have our process, we type it, we give it a name which I said should be descriptive. You bring your curly bracket, you start and you end. So what you have to do is to now put in the information. I made mention you need inputs and outputs. That is important. And then you need your script, the command that you are going to execute. So this command, you need inputs. So that one, you will define it here. And then outputs, you define it here. So this is what we are going to use. So now I'm going to go into a bit of detail. So I have defined my process trim. I have my curly brackets here, all right? And then I put in publish dir. You can see 3 of them here. So the publish dir are these 3. So publish dir, we use it to specify an output directory where Nextflow should place in the outputs. So what I have here, I've specified trimmed. So that means Nextflow should create a directory called trimmed. Now I also specify pattern. So in Nextflow, you can let Nextflow save certain files in a specified directory if it has a certain pattern in terms of the names. So here, pattern, I'm saying star trim star.fastq.gz. So that means that all files that have this name trimmed, in addition to the extension .fastq.gz. All right, so in other words, when I trim the raw width, the names I'm going to give them, I'll have these also in it. All right, so that's why I specified it. So, and I'll use mode equals copy to make a copy of the files. Let me just put it that way, of the files. All right. So this is for the frame width. And for fastp, it also generates reports. So we have reports that are generated in HTML formats and JSON format. So again, I specify publish DRL to make sure these files are also saved in appropriate directory. So here I save the fastp reports, both HTML and then fastp.json, both of them in the fastp reports directory. So that means if you have 3 samples, all of them are basically going to be in the directory here. So it's just a way to organize. So tag is a text that will be displayed. So I say fastp.sample. So that lets me know at that particular point at that particular time what sample is being processed by fastp. So that's why I place the tag there. But it may not be necessary for you. All right, so you don't have to. And then when we come to the inputs, so in Nextflow, if you're dealing with paired and reads, when we read it, you have the sample ID and then the reads. Okay, so this is a way to let the process know the format of the incoming data. So we are going to have a tuple, and then the tuple, we have a string, or let's say a text, that's the sample ID, and we also have the files, which are paths. So these are reads. That's what we have here. And then the outputs, I specify path star. That means we are basically generating files, everything. And then I give another one, path star trimmed star. And I emit, and I say trim width. Now, this one has a functionality. What I want to do is that for some of the outputs, in this case, files that have this name trimmed in their names, I want to, I'll just say tag them. That means I can access these files later on after the process has run successfully. Records of these files will still be there, or these outputs. Okay, let me just make sure everything is okay. Records of these outputs should still be there so that we can always call them. We can always reuse those outputs. So basically, that's the simple explanation I can give. But I will still give some links that you can use to read more about this emit. So once we have this, that means that after we have run this process, the outputs, the trimmed ones, we still have access to them. That's what it basically means. And so that is it. And then the script, this is the command we are going to run. Earlier on, I made mention the script, you should make sure you have a working command and then you can put it in the scripts. It's always advisable to do that first before you start the Nextflow script. So you have fastp. That's the command I'm using. Fastp, if you are dealing with paired end reads, you specify -I, lowercase I for read 1, uppercase I for read 2. And then you can give the outputs. Lowercase o for outputs read 1, outputs uppercase O for output read 2. Then I specify my reports. These are the ones here. And I also specify thread 5. And I also say should you detect adapter for paired end reads. Okay, so fastp can also detect adapters and then trim them for you. So it's possible to do that. So fastp has a lot of functionalities. There's just a simple one to get all of you started. I will leave the GitHub page for fastp in the description so that you can also read about it and use them if you want. Now you'll notice I have 2 double slash here. So this is to tell Nextflow that the command we are using, the continuation is in the next line. Sometimes when you put all the commands in one line, it becomes cumbersome. So a way to put the other commands in another line is to use the double slash. All right. So I have the same thing here, meaning there's a continuation in here. So that's what this simply means. So this is the process string. So we are going to get this into our script and then we are going to run that first and then proceed. That's what we are basically going to do. So we are going to test them one by one and then we will see how it goes. So now I'm going to shift to the terminal and we can proceed. All right, so process. Okay, we have process. We have already typed it. So it's process trim. I'm using an uppercase, curly brackets and curly brackets here. And then inside we will put our commands. So I'm starting with publish dir. So that's it, publish dir. Make sure you type it as it is. Double quotes trimmed, double quotes n, comma, and I'll say pattern, colon, single quotes, star trimmed, star.fastq.jz, single quotes again, comma, mode, colon, copy. We are making a copy of the outputs. We do same publish dir. We make sure the spellings are correct. So here I say fastp reports, comma, I say pattern, colon, I say star fastp.html. All right, that's what I'm going to put in here. Okay, so here we said star.fastp.html. Okay, but you can just say star.html. Let's actually put it this way to make it simple. All right, so star.html. Let's just put it this way. Okay, because we are going to generate an HTML file, so we are going to just copy that. Okay, so it's that simple. All right, comma, and then we proceed. We say mode copy. Okay, so this is how it's going to be. All right. So I will just revisit. So for simplicity's sake, I will just follow what I showed. So I will just say star fastp.html. This is what I'm going to give it. Okay. Comma, I'll say mode copy. Another publish dir fastp underscore reports. Comma, I'll say pattern star fastp.json. Comma, and I'll say mode copy. So this becomes publish dir commands. So just make sure everything is correct here. We need to make sure everything is fine. Okay, so just make sure it's working fine for you, then we can proceed. Okay, so that is done. I want us to go back to the script and then just look at something here. So if you take a look at the script, all right, we'll come back to the terminal and work on it. When we look at the fastp report, we said pattern star.fastp.html. So this should reflect in the outputs we have here. All right, so this output, it says sample id.json, but we want fastp.html. So that means I have to say .fastp.json. All right, the same thing with the HTML. All right, don't worry, we are going to retype everything on the terminal, but it's important you also get to know that. So fastp.html. All right, so that's how it is. I'm going to explain this in detail on the terminal. So let's shift back to the other terminal and then proceed. Okay, so we are done with the publish dir. So what we need to do is to add this. I'll just say tag. The tag, it's not really necessary, so I think I'll skip it for now. I'll just say inputs colon, and then the input colon, what I have, all right, it's, I'll just bring this path, not paths. So I'll just say tuple val for value into brackets sample id. I'll close it, comma. I'll say path into brackets reads. Okay, so we have tuple val sample id path reads. Okay, so this is how it should be for the inputs. You know, when we run Nextflow for the first time, look at how it was displayed. So we have the sample ID and we have the reads. So the reads, we had read 1 and then read 2. All right, so we are representing them this way. Again, for those who are new, just check my video on read file pairs in Nextflow. So I give a detailed explanation of this one. Okay. Again, for those who want the script, just check the description box. The link is there. Okay. So that is it. That's for the inputs, and then the outputs. Colon. I'll indent it. I'll say parts, double quote, star, double quotes. And then another one again, parts, double quote, star, trimmed, star, double quotes, comma, and I'll say emit, colon trimmed underscore reads. I explain it, I will explain again. So the emit here, it allows us, simply put, it allows us to still keep records of the output files which have this pattern in their names, basically. So that means we can still refer back and pick those outputs for some additional processing. So that is what we have here. So this is the power of Nextflow. All right. So this is for the output. Now let's proceed. Okay, so we can now proceed. We are now going to include our scripts. So we type scripts and then we bring 3 double quotes, 3 double quotes. And in between the double quotes, the first 3 and the last 3, we can put in our commands. This is how it goes. So this is where you put in the working commands that you are going to use. We are running fastp. And so we have to bring our fastp command. So I will start, I'll say fastp. I'll say -i. And then I'll have to specify the input. So this is read 1. Now we have to specify reads. Now this read here, we have read 1, read 2. And so you will say $ curly bracket reads 0, another curly bracket. So this represents read 1. Please take note of it. This represents read 1 because this is a list. We have 2 elements or 2 members in it. So member 1, member 2, and then indexing. Okay, we start from 0. Okay, so that's why we have it. And we say -i, uppercase I. So the same $ curly bracket reads 1, curly bracket close. So this is for the inputs, read 1, read 2. Space -o, that is outputs. Okay, so the -o, lowercase o is for output 1, output read 1. And here, because it's an output, we need to ideally use the sample name and give some additional description. So I will say $ curly bracket sample ID, curly bracket close. Remember we had it here, sample ID. And I will say .trimmed.r1 .fastq.gz. So I'm giving .trimmed so that it's different or it's separate or differentiates the raw reads from the trimmed one. So this gives extra descriptions for us. So this is for the -o. Okay, that is for lowercase o, that is read 1. Now we have -o uppercase. So $sample ID curly bracket close. And we say .trimmed.r2.fastq.gz. So this becomes the outputs for read 2. So we have $ curly bracket sample ID.trim.r2.fastq.gz. All right, so that's how it is. Take note that with Nextflow, you need to practice and practice, and then you'll be fine. All right, with different examples. For those who want tutorials with me one-on-one, you can also book a session or send me an email and we can arrange. All right, so it's just a matter of time. Now we have to add extra commands, but the line we have here, if you try to add all the commands on one line, it becomes very cumbersome and busy. So we will shift to the next line. And to allow Nextflow to take note of this, to tell Nextflow that, hey, the commands we are using, the continuation is in the next line, we bring a space and we say // a double slash here. Then we go to the next line, then we can add the other commands. So here we will say -JSON. That is for the report in JSON format. So $sample ID curly bracket, and I'll say .fastp.json. Now I have -HTML $sample ID .fastp.html. Now here I said $sampler.fastp.json because in our pattern here for saving those files, we said the pattern is star.fastp.html. So here the star will represent everything here, and then we have fastp.json, and then that is for the JSON format, and then fastp.html, we have that also here. All right, so this is also a way to streamline things and to make things easier for you. Now space, and we say --thread 5. Okay, here you can increase it, and at fastp there is a limit to the number of threads you can specify. So 5 is okay. You can also go a bit higher. I think it's 12 or 16. Beyond that, I think that's the maximum. So you should check the manual. So I'm using 5 because I'm using my normal laptop. So this one should be good for all of you. Then space, I'll say --detect_adapter_4p. Okay, to detect adapters and then trim them off. Now let me say that there are other options in fastp that you can use. Maybe you can filter based on length, based on quality. There are different things. There are different stuffs you can do with fastp. Okay, actually let me just type it here. If I say fastp, so there are several options here that you can choose from. So it depends on what you want, and so ideally what you should do is to contact your bioinformatician or statistician or whoever is responsible for the analysis, and then seek their advice on what to do. Okay, for some analysis you may need to filter based on length. Maybe for metagenomics, for example, there's the length of width, we have a good range, so you may have to trim and make sure you get those ones. Or for quality, you may want width with a particular quality. There are different things. So again, just talk to your expert or read papers and they will recommend what to do. All right. Okay, so let's get back to the Nextflow script. So this becomes our final command. All right, so we can proceed. Okay, so everything looks good. So for those who are also watching, you can also take a screenshot and then try to retype everything and then put them in your scripts. All right, so this is the command for process, or let's say this is the codes we are going to use for the trimming process. This is for trimming alone. All right, so just take notes of that. Okay, so now we are done with the trimming. I made mention we are going to start with the trimming first. So what we are going to do is to now go to the workflow section, and then we are going to trim. Okay, we are going to trim the reads. That's what we are going to do. We are gradually going to build it up. All right, so we will do trimming. You see all those things at once. Now we are starting with trimming, and then we will use it to also test. So to do the trimming, what we will do is to specify our reads. You know, we did a test run. So I'll just type that one again. So it's channel.from_file_pers into brackets params.reads. Okay, so this is how it's supposed to be. Now, because we are going to supply this to the process trim, all right, what we will do, a simple way to do it is to bring a pipe and say trim. Okay, I can just close the space, that's fine. So we have a pipe character, and then we have the trim. All right, that's what we are going to do. You can also just put the space, that's also fine. All right, so this one will work for you. All right, so once we do this, what we can do is to now exit and save changes. Perfect. All right, so now let's do an ls. We are going to see our script, which is here, which is the trim.nf. All right, So it is this script that we are going to run because we have written all the commands we need for now. That is the trim.nf. Okay. Again, you can do a cut. That's fine to see what you have in there. That is also cool. All right. So we are going to run it. Now, to run the script, okay, we need to make sure we have our input files, which are here. We have our scripts. And so we will run it. We will say Nextflow run, and we say trim.nf. Then we will specify --read like we did. We bring a single quote and we say fastq / star curly brackets _1 comma _2 this comma _2 curly bracket close, and we say star fastq.gz. We bring our single quote. So this becomes the command. So this one is what will help us to get our files in pairs. We have read 1, read 2. All right. So let's execute this script. So once we execute it, we are going to see something like this coming up. Okay, so that tells us that Nextflow is running. So the process is trim. So here is where if we had used the tag, we will see fastp there, but the tag, we can eliminate it for now. It's not really important, so we will skip it. All right. So now we have everything done. Okay, so once everything is done, you will see this coming up. Sometimes you also see what the time also displayed for you. All right, to know that everything is fine. So in some cases, the time taken for everything to run will be displayed for you. Some it will not be displayed, but it's fine. Once you see this, everything is perfect and great. Okay, so we have this. So once you have this, do an ls, and you are going to see the directories we specified. We have fastp reports, we have trimmed. All right. When you ls into fastp reports, you are going to see the reports for the different files we have. Okay. So this is what we have. Now, what you should note is that the reports we have, there are 6. The reason why there are 6 is because we have, for each sample, we have 2 formats being generated. We have the HTML and we also have the JSON. So you can read any of them. All right. Let's even look at them first. So I'll open them for you to see. So I have my fastp reports here. When I open it, I'll see them here. So there's the JSON formats and there's the HTML formats. They basically contain the same information. So I'll open the HTML for us to see what we have. All right, so we should see, this is for one sample. So we should see the reports displayed for us. So we have them here. It tells you what has been done. So we have this here. Before filtering, these are some information. After filtering, we have some information. Okay, so we see them all here. Okay, so that's what we have. So if you set stringent measures, then you are going to see some changes. We also have filtering results. So read past filters, so read with low quality. So these are the stuffs we have there. We also have adapter or bad. So basically you have this log file which can help you to also get an understanding of your data. So for that one, I will leave it for you. Okay, you can also contact your experts to help you interpret this. All right, so what you do is that you compare before and after filtering, or let's say trimming, and then you'll be able to have an idea if there has been an improvement in the data or not. Okay, so here for the most part, we use default settings for some of the options, and so that's why we see this. So you can make modifications if you know what you are doing and then compare the results you have. So this is just for one sample. All right, so you can just check and then see. So congrats for using Nextflow. And the beauty of Nextflow is that we had 3 samples, and so Nextflow automatically analyze all those samples for us. Let's say, yeah, so we had fastp trimming or filtering all the samples for us. We didn't have to write a loop or anything like that. So Nextflow helps us to automate our pipelines. It also makes it scalable, reproducible, and all that stuff. So with this, if you have any data set at all that you have to do is to just run it, all right, with Nextflow. So if, let's say, you have a different data set, once you have the script, you just have to specify where the files are, and then that is it. Okay, so that's the beauty of Nextflow. All right, let's proceed. We also have this directory trimmed, which has our files, the trimmed files. So ls trimmed, we are going to see the files there. So these are the trimmed files. That's what we have here. Okay, so the trimming has been done. Again, you can still explore this also using your file manager. And you also notice there's a directory called work. So this is a Nextflow design. So when you run your Nextflow script, automatically there's a directory called work which is created. So this directory will also have the outputs. All right, so that's where the output by default are stored. And so since we use the publish dir, let's just look at it here. Since we use the publish dir, a copy of the files were made into the specified directories. Okay, but the original files are also still there in the work directory. So you can decide to remove them. Okay, there are a couple of ways to remove these files. One approach is to just do rm-fr specify work, and that will remove it completely for you. Okay, so that one can be done. All right, so I'll just remove it because, and once we run Nextflow, whenever you run Nextflow, the web directory will be created, and then the files, if you are running the process again, that means new files are going to be generated. So there could be duplicates, or let's say there will be duplicates in most cases. So you just have to make sure you delete these files or remove the work directory completely whenever you are done with your analysis, or when you are done running Nextflow. Otherwise, you have files occupying space, which doesn't need to be so. You can also use the Nextflow clean command to clear the files as well. Okay, so just take note of that. But make sure that you already have the files copied or stored in another directory, so that when you remove the work directory, those files are not affected. So that is what you need to know. Okay. So that is for this section. We did trimming. Now, if we take a look at the overview, let's just check the overview. If we take a look at the overview, what we see is that we did trimming with fastp, and we generated our trim rates. What we also need to do is to run fastqc on the raw reads. Okay, we need to run fastqc on the raw reads. We need to run fastqc on the trimmed reads. All right. We need to run fastqc on the trimmed reads. And then after running fastqc on the trimmed reads, we need to now do multi-QC. All right, so this trim reads, actually, I think this line should have been here. It's fine. So the trim reads, we will combine all of them, run multi-QC, and then generate reports for raw and then trimmed reads. So this is what we have. So it's getting interesting. So just stay put and then let's proceed. So we will move to the next activity. So in the next activity, this is the rationale. Let me just show you. We are going to create another process. I will shift to that. We'll create another process called QC. And in the QC, we are going to run fastqc and we are going to run multi-QC. All right. So we are running both in the same process. The reason being that we aggregate all the fastq files, and so we can easily run fastqc and then multi-QC. So we run fastqc first to generate the fastqc reports. We aggregate using multi-QC and then we store them. All right. So here, because we have raw reads and then trimmed reads, we need to find a way to also separate them. So everything has been factored in here. and I'm going to explain everything very soon. All right, so let's proceed. Okay, so we will shift to the terminal and then we will continue. And there are things I need to explain to you first and then we can proceed. So we now know what we are going to do, so we are going to proceed. Okay, it's getting interesting here. Okay, so let's look at what we will do next. Now, if you take a look at this, let's just look at this script again. Here, what we did was to run trim. All right. Now, when we run trim, we still need to have access to the trim reads. That's why we have to use emit. Okay, and so that means we need to find a way to do that. So we will use the .set to get that information. So .set is a variable that will be used to represent the process, this process here. Okay, so once we have this, it's possible to now refer to the trim reads. You see that's also here. Okay, so we are going to basically do everything here. So what we need to do next is to make sure we get the trim reads. So to do that, we'll basically follow these commands here. I will explain a couple of things also here as well. Okay, so we are going to rerun everything again. Now I'll do this. I'm going to do a nano and I'll say trim.nf and we are going to proceed. Now, before you modify, let's even do this. Let's do an exit first. Before you modify, you can always try to make a backup of the script that you have. So I'll just say make the backup and I'll just make a copy of it. I'll say cp trim.nf. I'll say backup trim version 1.nf. This is just a backup. The reason why we are doing the backup is so that in case we maybe make some mistakes, we can revert back to the original one. So it's always important to back up your script or do versioning. Let me just put it that way. So if you are going to do a major update to your scripts, you need to make sure you give it a version. So what we have now is version 1. That's why I just have to copy it and give it that way. So this one, if you have to make a backup, I'll just make it as version 2. But for now, we'll just proceed with this name. So I'll say nano trim.nf. Now we are done with everything here. So let's go down to this one. Okay. Now what we have here, we are going to add something to it. That's what we are going to do. So when we come to this side, this line here, I'll bring a slash, meaning I'm going to continue the next line. And then I'll bring a pipe. I'll say set, and I'll say curly bracket trimmed. All right, or we can even say trimmed. That's fine. Whether trimmed or trimmed, that's fine. Okay. So here the set assigns a channel. Okay. Let's look at the explanation here first. So the set operator assigns a source channel to a variable whose name is specified as a closure parameter. So this is the description. So in this case, what we are doing is that the trim, this whole entire process, okay, the action, okay, we are assigning it to a variable called trim. And so when we assign it, then we can pick the outputs there and then process them. Basically, that's how I'm going to explain it as well. Those who also have other explanations, please put them in the discussion box. All right. So this is what we have. Now, when I set it this way, I can always refer to the trim reads. All right. So what I'll do next in the next line is that I'm going to say trimmed reads. Because of this emits keyword we use, it's possible to just say, so this becomes like a child to that process. So .trimmed, we want that child, that output, that label. So that is .trimmed reads. Now when we do it this way, all right, what we have to do is to add something else to it. So I bring a pipe and I'll say map, curly brackets, and I'll say reads. So basically what we are doing, that's the outputs, which are the paired end reads. Okay, that's what we are mapping. So mapping, let's even look at the explanation first. It's important. We'll come back to it. Map should be somewhere here. Let's just check it out. I had it here. Let's see. Let's go to map. Yeah. So map. So it returns a Q channel of value channel matching the source type. All right. And when we do a map, we are able to also do some formatting to the item or the output or whatever we have in that channel. All right. So what we are doing, the strategy that we are using here, that's when we map the reach, we are adding a label to it. All right. So this label is what we are adding. I'll just put it here. So it's dash, and I'll say tuple. We bring our brackets, and I'll say trimmed reads. All right, so tuple, and so what I'm doing, that in addition to the trimmed reads, the fastp files, so I'm adding additional information. This information is for trimmed reads. It's a label, okay, because when we combine the raw reads and the trimmed reads, we need to find a way to differentiate them. So that's where this description comes in. All right, so tuple, comma, I'll bring double quotes, dollar, it's dollar, so dollar, curly bracket, reads, 0, curly brackets, comma. So this represents the read 1, comma, the same reads 1, like this. So this is what we have. Just take note of it. And then once we have it this way, we can now close the brackets. That's for the tuple. And then we add another curly bracket again. All right, so this becomes the mapping that allows us to add additional information to what we have, i.e. the trimmed reads. Now we bring this and remove the next line. And I'll say pipe, and I'll say set. Say final trim. All right. So when I set it again, there's a channel, so I'm adding a new variable. I'm assigning it to a new variable that will now also contain this information. And I'm saying final trim because I have processed everything. I have my final information. This is what I have. Okay. Now let's do this. Before we even proceed, what I want us to do is to do a quick test here. Okay, so that's what we have, the final trim. All right. Let's say final trim.view. Let's exit. Let's save changes. And then let's just record this command again. Let's run it. So when we do the final.view, that's what is going to happen. Final trim.view, we are going to see something coming up, right? After rerunning that same command, we don't need to change this. So after trimming, after processing, you will see the information that is added to it. So notice the information we have added, the trim reads. Okay, so in addition to the trim files, we have read 1, read 2, which we know we add this to it, this tab. So this information will be needed when we are running fastq and multiq, so that we can put them in the appropriate directories. So that is why we have that. Let's clear the screen. Let's open the script again. Okay, we are still on the script. All right. So when we scroll down, let's scroll down again to where we left off. We don't need again, we don't need it. I repeat, we don't need this. It was just there for us to see something. Now we have the trimmed width, which is great. Okay, we also need another information, that is the raw width. So for that one, we say channel dot from file pairs params dot width. All right, we bring our slash, move to the next line, bring a pipe, and we do a map again. Map width, and we say tuple, and again here we add raw width. This is the tag. Comma, and we bring dollar width. Here we do something slightly different. So it's dollar width 1 0, because here how the files will be presented is slightly different. So we have to do this accordingly. All right, and then we bring our curly brackets, and then we bring our double quote first. So we are going to have it something like this. So dollar curly bracket width 1 0, and then we add comma, and we say dollar. It's supposed to be double quote first. So double quotes dollar curly bracket width 1 1 curly bracket double quotes and that curly brackets again. It's supposed to be this way rather. So I'll just go over. So we have the curly brackets to close this. We bring our brackets to close the tuple, and then we bring our curly brackets again. So this is what we should have. So we have it this way. So we should have it something like this. So your double quotes dollar curly brackets width 1 1 curly brackets double quote close and the tuple and the map functionality. We bring our slash, we come here, we do set raw. Here you can also say raw width, that's fine, but I'm just keeping it simple, so I'm just saying raw. Okay, but you can add raw width. Okay, so that's fine, so I'll just say raw. Okay, so this becomes the one for the raw width. All right, so again here we can test. I can just say raw.view. So I'll do this. I'll exit and save changes, and I'm going to rerun Nextflow again. So let's rerun it now. All right, so we can see that information also displayed for us. So we have the raw widths, which are here. Okay, so we have all the information that we need for the next activity. So don't worry, for those who still want extra explanation, you can always book a session, or you can always contact me for extra tutorials. All right, or if you have a project too, you need some help, you can always contact me. Okay, so this is what we should have. Okay, so that is great. So now what we will do, we'll just clear the screen. We will open the script again, that's trim.nf, and then we are going to proceed. So here we don't need this again, it was just for testing. We don't need it, so we have that done. Now the next thing we have to do is to do this, is to merge the final trim and the raw. So that means the trim width and the raw width, we need to combine them basically. So here we use the dot mix. So I'll say final trim dot mix into brackets raw. So we can do something like this. All right. So when we do it like this, we can say dot view. Now let's exit. Let's rerun this to see what we have. Good. So once we mix them, we expect to see the raw widths and then the trim widths, all like this. Okay. So this means everything is okay. So we can proceed. Now, what we need to do is to now group them again. It's additional process. So we need to group them so that we have the raw widths as one tuple and then the trim width as another tuple. So let's clear the screen. Let's open the script and we will add something else to it, which is here. So instead of dot view, we will need to add dot group tuple. And now I can say dot view. So we mix dot group tuple dot view. Let's see what we get. We will run the script again, and then let's see what we get. So because we are grouping, we need to make sure we have all the necessary files first, and then we'll group them using the group tuple, and then we'll see how it will display. So let's see how it's going to be displayed for us. Great. So because we are grouping them, the raw widths, we will group them first, and then we're also going to group the trimmed widths. Okay, we see them also here. So we have trimmed, we have raw. Okay, so we are going to get something like this. Of course, with the view, because Nextflow does parallel processing, some of the information will come first before the other. And so ideally what we should do is to set them, but nevertheless, this one should also work fine for us. So we group them first and then we can now do the activities. Okay, so we are going to see something like this, but it's fine. We will proceed because whatever we have there, it's fine. So when we group them with the group tuple, we have raw reads, we have their files, frame reads, we have respective files. So it goes in that order. This is how we are going to see it. But the most important thing is that we should see raw reads. For a tuple, we should see only the raw reads. And then for another tuple, we should see just the trim reads. That's what we see here. Okay, so this in a way helps us to organize ourselves or organize the files, and we can push them for further processing. Another thing you should also take note of is the numbers that are here. So this numbers tells you the, let's say, the number of activities going on with respect to that particular process. So here it says 3 of 3. So the of 3 here refers to the total number of activities for that process, or let's say the total number of time that process is being run. So in other words, it helps us to know how many samples we are processing. So here's 3. But when we do the next step, which is QC, we are going to find that it's going to change to 2, because here we are going to run QC for just raw reads and for trim reads. So these are 2 groups. All right, so that's what you should take note of. Now let's look at the scripts. All right, let's look at the scripts that we have. So this is the script. Now what we are left with is to add the process QC, which is this one here. So I'm also going to explain a couple of things. So here with the QC, I already described it. So here we also specify publish DRR, 2 of them, one for fast QC, one for multi QC. Okay, because we are going to generate fast QC reports, we are going to generate multi QC reports. So for each of these reports, we have this description to tell whether it's raw reads or trim reads. and the pattern, okay, to tell us what kind of files should be stored in that specified directory. So the same goes for this. All right, so we have our inputs description with 1, with 2, as well as these ones. All right, so same formats, we'll go to the terminal and then we'll proceed. Let's see what we have. Okay, so let's clear the screen. Let's nano into trim, and then let's create the other process, which is QC. So again, when we come here, it's process QC. You'll bring your curly brackets and you will say publish dir. So here is fastqc underscore reports dollar description. We will explain description later on. So this is what we should have, comma, and we have pattern star fastqc star single quote. So pattern colon, we bring our single quote star fastqc single quotes, comma, mode is copy. We do publish dir again, and here it's multi qc underscore reports slash dollar description, comma, pattern colon star multi qc star, comma, mode copy. You need to make sure everything is okay, spellings are correct. So we need to make sure we check and then see what we have. So multi-QC report, yeah, everything is okay now, so we can proceed. Now we can add our inputs. So here again, it's tuple, and then val for description. So the description is whether it's raw read or trim reads, comma, path. Here we have path with 1, comma, path with 2. Take note that these things, you always have to read the Nextflow documentation. It tells you what to do. So based on the processing you are doing, you need to make sure you specify the format in the process. Okay, from the channels, you need to make sure how the data is being presented or displayed. You specify the appropriate format in the input section of the process, which is going to process those files. It's very, very, very important. All right, now we go to the output. We say part double quote star double quotes, and that's it. Here we are not using emit because we don't need to process any files again. Okay, we do it here, that's fine. So here I'll say script colon 3 double quotes, another 3 double quotes. Inside we will start with fastqc and we say $read1, $read2. We have them here. After running fastqc, we have to run multi-qc. So it's star fastqc star. But then with multi-qc, what happens is that it tries to clean your files. And so in some cases, if you have files with some names in common, it will lead to conflict, and one file will override the other. So to prevent that, to use the names, the file names as they are, we say dash full names, and we say star fastqc star to maintain the file names. All right, that's what we have. Okay, so this is it for the process QC. So here we run fast QC, we run multi QC. That is what we have. Okay, so ladies and gentlemen, we are almost there. The moment of truth is here. Okay, so this is what we have. And so what we can do is to exit and then save changes. Okay, before we even exit, we need to make sure we specify the QC also here. So when we come to final trim, this side, instead of the view, we bring a pipe and we say QC. This is what we need. All right. So we can now exit and we can save the changes. Okay, so now what we can do is to rerun the command. All right, so let's rerun the command and let's see what happens. So here you will see that it tells us what's trim. That is what it's doing now, and it says 0 of 3. So it knows what is the expected number of trimming steps, or let's say trimming activities. So 3 of 3 is done. Now we have 0 of 2 QC. So that's what I was talking about. So QC, there are two. QC is going to be run 2 times because we are running QC for raw reads. We are running QC for trim reads. So that's why we have 2 of them here. So fast QC will be run on them. After that, multi QC will be run to aggregate the files, and then voila, we are done. Okay, so this is how we are supposed to see this. All right. Okay, so everything has been done. So we can see the output here. So we also see the dates and the time it took. Okay, so now if we do an ls, we are going to find fastp reports. It's also already there, fast QC reports. Yeah, this one's, yeah, this is new fast QC reports. We have multi QC reports, we have trimmed. Okay, some of the directories were already there because we had earlier run Nextflow. Okay, so for the fastp reports and the trim, they're already there, so we run it. So if you already have directories existing, then it's advisable to remove them, okay, or move them to another location to avoid it being overwritten or being modified. All right, so or you can also remove it completely and then rerun Nextflow. All right, so let's do it. So actually, now that we are doing this, I want us to just rerun Nextflow again. Let's remove the files to make sure we have a fresh directory. We are removing all the files and we are going to rerun again. So fastp reports will go, fast QC reports will go, multi QC reports, trimmed, and then work. These ones we are removing them. All right, so that we have just fastq and then the trim.nf. Then we are going to rerun Nextflow just to make sure we have what's a new file generated. We just want to make sure we have the right file. So we are going to rerun it again and then see. So if you look at the time here, it says it took 1 minute 8 seconds. So that is what we should expect, okay, for this one to also tick. Then we can now explore the outputs. All right, so now we have run it. We have our outputs, which is great. So let's clear the screen. Let's ls, and we are going to see the output. So this is what we are expecting to get. All right, so ls into fastp reports. You will find your reports. We earlier on explored it. ls into fast QC reports. And then what we are going to see that we are going to have fast QC report for raw reads and then for trim reads. Let's ls into, let's say, raw reads. You see them there. When you ls into trim reads, you also see them there. You notice the names as well. ls into multi QC reports, you see raw reads. Okay, you also see the trim reads reports. All right, so it's been so cool. This is organized. All right, ls into trimmed, then you are going to see your files there. Okay, so this is how Nextflow makes things easy for you. Okay, of course, initially you have to make sure you put in the right commands. You put in the scripts, everything. And once everything is done, you can always reuse the scripts on different data sets as well. That's the beauty of Nextflow. So once you have it, it's just a matter of you calling Nextflow like this one, and then specifying where your reads are. Okay. And also I would advise that you specify the absolute paths for the reads. Okay, it's always important to do that. Here I use fastq because I am already in that current directory. Okay, but ideally you should try to use the absolute paths. That's something you should take note of. I will come back to this later. So these are the files we have. Of course, you can explore them. Let's see. If you have them on a remote server, then you can use SCP to transfer them. I already have a tutorial that shows how to transfer files from remote Linux servers to your local computers using SCP. So check that video out. The link is in the description box. Now I have mine on my laptop, so I have the files here. So fastp reports, we checked fastqc reports, we have them here. There's the raw reads. I can just open them. It's so cool. We can see the reports here. Okay, so here everything is okay, minus the per base sequence contents, which we see somewhere here. It was wobbling a bit, and we see this here. So this could be indication of some issues. Okay, so again, when you check the fastqc page, there's a help page that lets you know how to interpret these outputs, and I've already covered one tutorial of such nature, so you can just check out and see the possible reasons. So this is a proportion of the bases, the 4 bases. So here, what we see here, there seems to be a bias, okay, especially at the start, but there could be reasons and all that stuff, which is beyond the scope of this tutorial. Okay, so just take notes of that. So this is just a quick overview of fastqc. We also have, so there are others here, and so you will notice we have several fastqc files, and reading all of them is a cumbersome process. Okay, hence we running multi-QC to aggregate the reports. Okay, there's also for the trend reads. Okay, we have that here as well. So that's for it. So when we run multi-QC, we are able to aggregate the fastqc reports. We have them here. This is for the raw reads. So when you open this single HTML file, you have the report for each of the files. So this makes it easy for you to compare because everything is on a single page, so you can easily compare them and make inferences as well. So you see all of them here. Okay, so that's for the fast QC and multi-QC. So when you look at the reports with the fast QC, one of the things you can do, we see that the reads quality reduces towards the end. Okay, this is something to be expected when dealing with Illumina reads. So what you can do is to trim. Okay, so here I think the default quality threshold is 20. So if we had increased it to, let's say, 28 or maybe 30, then that means, let's just go back to maybe 30, then that means that we could have trimmed these ones. But anyway, that is for another day. Okay, so this is for multi-QC. All right, so that's for the raw reads. If you also want to check the trimmed ones, we see that also here. So we can see that, and you can also check their names. So it uses the names of the files themselves. We see that also here. So this is so cool. So this is the power of Nextflow, all right? And you can just check them out later. I am also planning to make some tutorials that cover entire pipelines. I'll put them on my YouTube channel, also as well as my Patreon channel for those who also want to check and support. So this is to help you get started. Again, those who want the Nextflow script, if you want the Nextflow script, let's just get back here. If you want the Nextflow script, which is here, you can just check the description box. The down link is there, and you can use that to support this channel, right? So this is the end for this tutorial. This is for trimming, and subsequently we are going to update the script and then use it to do mapping and probably RNA analysis and etc. So this is to serve as a guide, and then later you can also contact me, especially for those who want more tutorials on Nextflow. Okay, so That'll be all for this tutorial. And so here we've covered what? Getting FASTQ files into a channel, running FastQC for the raw reads, getting trimming done, running FastQC for trim reads, getting multi-QC. And so this becomes it. Okay, so that'll be all for this tutorial. And if you want more Nextflow tutorials, then please check the playlist right here.